So I know it's post-lunch, and there's like a bunch of other talks going on right now from two from Netflix, one from OpsMX. So to the people that came to this one, thank you, much appreciated. So this is a talk about using Spinnaker to fight fires, but a lot more just kind of like, I'll say philosophy around fighting fires with automation. So let's go ahead and get started. So required slide, who am I? Why am I up here? My name is Robert Ross. People like to call me Bobby Tables, if you're familiar with the XKCD comic. A few muted chuckles, so yes. I am a software engineer. I previously worked at Namely, which is a HR software as a service company. I built a lot of the platform that Namely runs on today. I introduced Spinnaker at Namely. If you were here at Spinnaker Summit last year in Seattle, I spoke there about some of our automation there. Previously, I worked at DigitalOcean. I also built a lot of internal tools, broke a lot of stuff as well. If you used DO and it broke like 5 years ago, I apologize. Many other reasons to be here, because I've been breaking software for over 10 years, probably more like 15 actually. And I'm also never this photogenic, so if anyone could capture something even just like half of this, I'd honestly be just so happy. So I currently work at a company called Hydrant. My current day-to-day is it's an incident response tool. What we do is we help teams handle and respond to incidents quickly with process and automation. I'm the co-founder CEO of a business, small team, headquartered in New York City. Awesome tools. And this is Patchy the dog, if you like puns. So let's talk about fires, Spinnaker, and you, the audience. So this talk is about incidents, learning from them, and adding automation for them afterward. We'll learn about some of the basics about analyzing incidents. What we'll do is we'll also redefine what Spinnaker really is, and then we'll decide if we're going to automate or not. If you're in Lauren's talk, this is actually a great one to kind of actually be in right now. But first, we have to do something that I found very challenging to do. What even is an incident? So in my quest to define the word incident, you come across a varying array of options. So dictionary.com says an individual occurrence or event. Okay. Merriam-Webster says something dependent on or subordinate to something else of greater or principal importance. I had to read that like 25 times before that really even landed halfway. And then Lexico said an instance of something happening, an event or occurrence. Okay, so basically, based on these definitions, it's anything that happens, which is not really how we use the word incident. So why do we always kind of use the word incident negatively? Email incident, deploy incident, conference incident. If I say these, you might have your own registered versions of what these might actually be. An email incident. We sent hundreds of thousands of emails to the wrong addresses. That would be a terrible email incident. Or deploy incident. That deploy went awesome. Got you with that one, right? You thought of something terrible. Conference incident, my talk was like a 5 out of 7 on a ratio scale. But that's not enough, right? So I even asked the internet why I used Stack Overflow's English and Language and Usage Stack Exchange website. Why does the word incident have a negative connotation associated with it? And then somebody who was extremely helpful said, because that's its typical usage. The more you know. Thanks so much. So eventually, the internet did provide me a lot of help. Euphemistic meaning, event that might trigger a crisis or political unrest, first attested in 1913. And further solidified in our brains as crisis or unrest on February 28th, 2017, when Amazon S3 went down. But here's the thing. In all good fun, the word incident is, it's not a bad thing at all. Incidents aren't bad. They really are not. By definition, they really are just an event or occurrence. We've kind of made them bad. John Allspaw said, incidents are unplanned investments. The second time I've seen this on a screen up here today. But what I'll add is they're only investments if we actively learn from them after they occur. An incident could happen, we could do nothing, and then it's not an investment at all. It's just something that happened. So we have to learn from them afterwards. So what we're going to do is we're going to use a past incident to learn from and sprinkle some automation on. And if that scares you, the word sprinkle, you're in for a treat. So let's move towards automating something out of a previously occurring incident. And this is all real world, actually. So we're deployed to a Kubernetes cluster in a major cloud provider. We use the default deployment type provided by Kubernetes to manage our application. It's a big old monolith. It's been in production for years, and it's been there in several forms. I'm sure many people here know this last bullet point all too well. And lastly, we went into a code freeze, sometimes known as a moratorium, during the holidays to prevent any fires from breaking out. And what actually happened is that the moratorium actually just took us down. Whoa. Our large application had a fun hidden bug, a memory leak. And when you consistently deploy, a memory leak can be missed entirely. We stopped deploying out of fear of shipping a bug, which caused a bug. And this is the classic story. A lot of big businesses have actually had this issue. So let me tell you, so really this is what happened to us. Our last deploy went out before the moratorium. Great, we're going into the holidays. Last deploy is going out, CI ran. We deployed using Spinnaker. Time passed, and then pages went off 2 weeks later. How are we getting page right now? Nothing's changed, right? So what actually happened? Let's talk about the incident. The core application is written on top of Ruby on Rails, microservices on the edge, Rails 4.2. It is using Postgres as the primary database, hosted on Amazon Web Services. Rails 4.2 has a bug that causes the creation of prepared statements for every query that uses dates in a where statement. So to say that differently, if you were to use a where statement in Rails using Active Record, if you're familiar, that says anything below this date or ahead of this date using a less than or greater than operator, it would create a separate prepared statement for each of those queries. So that meant that anytime we had something that came in 5 minutes ago, as time shifts, 5 minutes ago changes. So that meant that every query had a new prepared statement that is stored inside of Postgres. So that means that Postgres has a crap ton of prepared statements created, stored in memory for all connections. And a prepared statement, for those that are unaware, is the plan of how a query gets executed. So Postgres is storing these prepared plans in memory for every single connection, for thousands of connections for the application. And because we deployed regularly, the connections would close to Postgres, and Postgres would clean up all of the prepared statements that were associated with that connection. But when we stopped deploying, memory grew and grew and grew on the database. And eventually, the poor innocent database started swapping. One of the scariest things that can happen to you as reliability engineering, and this caused the trickle effect of the entire website kind of going boom, boom. So what did we do? Well, let's just restart pods. We can't just start deploying again. So to solve the problem, we added some automation. And by automation, what I really mean is a bash while loop that simply picked pods at random and deleted them every 15 seconds. Because we're crunched for time. We don't want to stick around. So we just came up with a simple little thing that we just kind of manually applied to Kubernetes, didn't really tell anyone that that's what we did, and then scurried off, and that was just kind of the solution until we came back and started deploying again. Suddenly, our database out of memory incident was resolved. It's fine. Who cares? Deleting pods at random, though, what could possibly go wrong? So here's the thing with automation. This is going to be a key point for this entire talk. It may solve a problem or two, but it will create others. It may create others that should really like s/may/will create others. We had absolutely nothing that managed what we called killa for thrilla, this bash while loop that was just killing pods at every 15 seconds at random. So now we kind of probably should have had another process to manage our process that was keeping us alive. And this is the problem with complexity, is that as you add things that are keeping you up, like keeping you up in the sense of like your website still working, not up at night, they add complexity in themselves. Nobody knew it was even there minus the incident responders. This thing could have been going and going, and somebody would have gone, oh, what is this thing killing pods every 15 seconds? A natural inclination would be to get rid of that. And they would have no idea that that was actually the thing that was life support for all of the website. There's a paper from 1983, which is like where I'm pretty sure we actually solved all software problems, and we're just like slowly catching up, called Ironies of Automation. And it has a bunch of great stuff, and a highly recommended read. It's about 5 pages long, I think. But physical skills deteriorate when they are not used, particularly the refinement of gain and timing. This means that formally experienced operators who have been monitoring an automated process may now be an inexperienced one. If they take over, they may set the process into oscillation. So this is what I'm going back to, is like, we built this automation to save ourselves. And we were keeping this process there to kind of, prevent the website from going down. But if you imagine if we had left for a year, maybe even 6 months, and somebody else comes in, they're not an experienced operator. They don't know why it's there. And they're going to get rid of it, and they're going to set the process into an oscillation, as deemed by Ironies of Automation. We build automation out of perceived need. And the people that maintain software without the automation tend to be the people that also build it. But software automation is software, and software, as we find all the time, breaks. Therefore, we must be cautious about the automation that we introduce into our systems, because you're adding complexity with every bit of automation that you're trying to reduce complexity. The irony of it. For example, Spinnaker can be used for our incident. In theory, we could move our killer for Thrilla to Spinnaker. Spinnaker offers cron triggers. It can update Kubernetes resources. Another subtle advantage of it, it's battle tested. You could actually build our bash script that was killing pods at random in Spinnaker. This is an option. And if I were to do it again, I would do it this way. I would create a cron trigger in our deployed instance of Spinnaker every 1 minute. And then I would configure a patch step for our Kubernetes manifest that updates an annotation on the pod, which will give me new pods every minute. I've resolved the problem. And it's not hidden away. There's auditability. I can see when it last ran. People can't delete this randomly if they don't have that proper access control. Is this a bad idea? Maybe, kind of. If we wrote this ourselves in Bash and deployed it, is that actually better? I don't know. Depends. The moratorium was during the holidays, and we didn't want to lift the moratorium just because of this memory problem. Spinnaker is designed to initialize and run tasks. So in my opinion, use it to initialize any kind of task you can. Because for this moratorium, to really go into this, there are a lot of factors that kind of go into this. This was HR software that included this moratorium. And when you go into the end of the year, you have what's called year-end, year-start. And what that introduces is taxes are ending, so payroll kind of has to button up a ton of things using the software, and then benefits begin on Jan 1. So all of a sudden, you have a lot of things happening in the holiday season. So the moratorium was kind of sane in a lot of ways. So we had to kind of get around the moratorium in some ways, and that's why we built a bash while loop. Because here's the thing that I want to drive home here. Spinnaker is nothing more than a workflow engine. Great, nobody's lunging at me. That's good. It's a workflow engine that comes with batteries for continuous deployment. If you really look at the guts of Spinnaker, it's a workflow engine that's really good at deploying things. Unpopular opinion, maybe. Spinnaker should be the default for your incident one-offs. It's a deployed solution that you monitor and observe already, right? It's great at running tasks and making sure that they keep running. It has auditability, whereas a one-off config change may have no audit trail in the heat of the moment. And when you need to actually figure out why a process or script or something exists in the first place, figuring out who built that could be a challenge in itself. You can keep strategies around and disable them easily. This is another advantage. If you're building one-offs, it's never a one-off. You should always keep your one-offs around. I can't tell you how many GitHub gists I have of one-offs that I still use all the time. And that's one of the great things about Spinnaker pipelines is you can actually keep these pieces around and treat them as small units of work. Because Spinnaker is great for small units of work. And that's great news for incident response. This is a pipeline to actually roll pods. There is a way to actually click now in Spinnaker, you can do a rolling restart. But previously, we just had a pipeline that was one step. And that's OK. It's OK to have pipelines that are really good at one thing, because they're very easy to execute. And for incidents, small automations matter. By keeping automations small, restarting pods as an example, we give more possibilities to responders. You want to create what I call levers and knobs for incident responders to pull and turn to remediate issues. You do not want to get fancy when you create pipelines for incident response, because then you're orchestrating orchestration, and that's a problem, right? You're getting even more deep in the weeds of actually trying to resolve incidents with pipelines. So for example, don't create a pipeline that restarts pods, increases memory, and notifies the Slack room. Create individual things, because it's pretty rare that you're ever going to have that usage again, because you might create that pipeline for an incident that has already happened, but here's the thing, that incident is likely not going to happen again. You will likely need a way to roll pods again. You will likely need a way to increase memory. You will likely need a way to notify people. So create them as small units, or levers and knobs. And now you might be asking the question, well, what if Spinnaker doesn't support the automation that I want? Good question. Build it yourself. Because Spinnaker has webhooks. You can build an application that can be initiated via Spinnaker's webhooks in a webhook stage. And this creates less strain on you as a developer in your software and how something is initiated. I've worked at 8 different companies, and almost every single one has an internal application that can run random tasks. And it's internally hosted on the VPN. It's some Rails app, PHP, Django, and it just runs random things. But the problem with that is that now you're hosting that application, and now you have to have automation to deploy that and monitor that and make sure that it's always still running if the process dies. The irony of the automation. And not only that, it creates uniformity in how you trigger levers and knobs for applications. So use Spinnaker expressions to send dynamic payloads. It's a great idea to be able to parameterize these small units of work. If I build an application that knows how to flush a queue, any old queue, PubSub, Kafka, I don't know, something that just acknowledges all the messages, I can build the software that'll do that. Spinnaker doesn't have that primitive, but I know how to build that. But I don't want to build the thing that has a UI to trigger this, ACL, logging in, all of that. I don't want to build that. I just want a way that I can just push a button to make that automation run. And Spinnaker is a great way to do that because it unlocks a world of possibilities. You can build now very small units of automation and trigger them via Spinnaker. Because standardization goes a long way. Why would you want to create another web app? It's not fun sometimes. I don't know, your life. I've created web applications for triggering simple tasks like restarting, scaling, flushing queues. But now I have another web app to host. I have to make sure it's stable, live, has tests for other pieces of it. But if you're already using Spinnaker for deploys, you have a tool that is already hosted, that has ACL, has audits. There's no reason to not use it as the way to push buttons. It's a great candidate to actually start adding small automation tasks and incident response pieces to. I'll say it again. Spinnaker is nothing more than a workflow engine. Closing up, and I'm like real quick on my time here. So Spinnaker is more than a continuous deployment tool. It is a workflow engine that can run tasks at scale. Big, I mean, just like look at that thing over there. That's a lot of big names using Spinnaker to deploy things. It can run tasks at scale. That is proven. It has all of the primitives necessary for defining small units of work, what I call levers and knobs. When it comes to incidents, Spinnaker can be used to give responders the necessary tools to mitigate quickly. Engineers have the best intent when it comes to resolving an incident. And they will do what they need to do that needs to be done to resolve an incident. And giving them these quick ways to do those things that is repeatable is key. So small units, define your small units of work as pipelines or strategies for engineers to use in Spinnaker. Levers, make the levers easy to pull with sane defaults. Knobs, give the ability to parameterize the tasks using Spinnaker expressions to give slightly more flexibility. And implementation, add only what is necessary for responders based on what you have learned from past incidents. Don't add random tasks because you think you'll need it. This is a gotcha in all incident response is trying to pre-optimize for an incident that actually hasn't happened yet. And it can be a huge waste of time sometimes. Thank you for coming to this incredibly little quick talk. But my name is Robert, Robert at FireHydrant.io. I'm at Bobby Tables on Twitter. That's my GitHub. That's our website. I'm also a San Diego native. So if you want tips and tricks on where to eat, drink, go to the zoo, things like that, please feel free to find me and have a conversation. Thanks.
Thank you. All right. We're going to take some questions here for a few minutes. But before we start taking questions, I want to make a quick announcement. Please go onto the Spinnaker Summit app by Modev and rate and give feedback for this talk. The conference is collecting feedback, and we'll give feedback to the presenter. So please go on, fill that out. Now, if there's any questions, please raise your hand.
You mentioned something about controlling access to Spinnaker as sort of the gateway, because a lot of these one-offs, right, you don't want to give in the hands of everyone.
Sure.
How did you do that, or what is the access model at FireHydrant?
We were just using the baked-in stuff. Like we didn't do anything fancy. Like we're using like the developer GitHub teams like mapping for who can actually access things. Yeah, sorry, nothing fancy. I wish I had a better answer.
Thank you.
Question in the back on the Adobe booth.
So you mentioned you keep the pipeline small and...
Is that on, actually? I can't.
Hello? Can you hear me?
Yeah.
Oh, sorry. So you mentioned keep the unit small and keep the pipeline small. Over a period of time, wouldn't you have a lot of pipelines? And if so, how do you manage all of those different use cases that might be very small units of work and combine them together over a period of time when you have more workflows coming up or more use cases to combine them together?
Yeah, so The reason I like keeping those pipelines as small units of work is that because Spinnaker has the ability to trigger other pipelines from pipelines, then you can start to create those orchestrations if you need to. I like to think of Spinnaker pipelines as kind of Lego bricks, where you just want to give the ability to really build what you want to build, and then you can kind of build the instructions around how that actually gets built, if that kind of makes sense. You can have, and it makes a ton of sense for certain one-off things to have a pipeline that's like, for deployments, that's a little bit different. But I think for automation tasks, maybe as like scaling up things or whatever have you, I think those are best as small units of work that has maybe another pipeline on top of it that orchestrates those small units. Because again, this is more like giving options to developers when they really need them to do certain things. Because a lot of companies don't have SSH access, they don't have the ability to really get into a kernel. So that's really where this talk is coming from, is addressing those kind of needs. Yep.
So these pipelines are tied to each application or projects, right? So how do you replicate from one to another?
Yeah, that's a good question. How do you replicate from one to another? So that one is kind of hard because you do have to kind of copy a pipeline onto another application in Spinnaker to make that work. That's why I think what we've done is like we've made an application that isn't tied or backed by any resource in Kubernetes and only used it for like webhooks. Because you can still get away with like running pipelines that aren't backed by anything in resources. So that's kind of how we've gotten away with that.